sports, tennis courts, asphalt sports, running track, tacky sacks, sports, tennis courts, asphalt sports, running track, tacky sacks, sports, tennis courts, asphalt sports, running track, tacky sacks. One take. Remember, after finishing the webinar, send me an email. I'll send you the quiz, and when you return the quiz, I'll send you your certificate of completion. So remember, did you do your quiz? Did you do it? Thank you. After this webinar, essential employees should be able to have a really good grasp of the importance of the subtleties of the athletic asphalt that's really required to be installed for a successful tennis court or running track. And this is just based on some experience I've had over the past dozen years or so with clients that install athletic asphalt and coatings that go upon them or running tracks. A lot of the people I work with in the athletic world have asked me to present more during this time, and so that's why I'm going to head down with tennis courts and running tracks. Many different asphalt mix design and process control efforts exist, varying across the nation. However, we need to make sure that we follow the practice that exists in the state that you're working, and the best resource available is the Asphalt Institute's Asphalt Mix Design Methods. It's known as Manual Series number 2. So if you want the full book, reach out to the Asphalt Institute, or just make sure you hire a producer who uses MS2 as their design guide. So a lot of different products go into asphalt. It's a big world that we live in, so we need to make sure that we choose and select products that will perform for this application. In many cases, it's similar to roadways and runways. However, specifically to impurities and things like that, it's different to roadways and runways. Crushed particles are good for nearly every asphalt installation. Athletic is no different. Proper liquid asphalt is equally as important. We need it to be soft and pliable, but tough with tenacity as well. And importantly, we need to produce it to good mixture properties and do quality construction of the density in place. We'll talk about those all throughout. Fairly standard and important item to be aware of is the proper selection of air voids. For our work in athletic, we're always going to choose air voids in the laboratory between 3 and 3.5% air voids. We don't want to be higher and we don't want to be lower. That should be our target air voids. And then there's plus or minus. Plus or minus will be very tiny, and the dropping of air voids to a lower level will cost money because it requires a little more asphalt cement. But that's okay, because for our application, we need to have higher density and a mixture that'll perform better. Lots of asphalt facilities around the nation. I just recommend you reach out to the producers who are National Asphalt Pavement Association members or members of the local asphalt pavement associations or the American General Contractors Associations in the states or provinces around North America. They do a really good job in educating suppliers so that they produce the highest quality product possible. Air voids are going to be the room that allows for expansion and contraction of the asphalt over its entire life. If you just kind of look to the right 2 columns with percent maximum theoretical density and in-place air voids, they're complementary. So if we can get an in-place density of 95%, that means there's in-place air voids of 5%. So we really want to target that 4 to 7% area
So most should probably compact between 94 and 95% theoretical for athletic applications, not only on the mat, but on the joints as well. Installation, we have lots of GPSs available that can control our elevation and our cross slope. Excellent pieces of equipment. These should be used. You'll be checking the elevation as you go along. Again, very important for planarity, very important for building to the proper grade and cross slope. And then there's going to be hand and foot inspection and checking for levelness and trueness after the rollers are on the mat. And you have to do that across the mat as well as between the joints that you're paving. It's just the worker's tool. They're targeting 1% cross slope. This one here looks like 0.8, so they're relatively close. They're going to really want to pay attention because they have to make the water run off the court or the running track. Real important items is when you're an installer of asphalt, make sure that the architect has given you an adequate minimum lift thickness to do your job. That means you can get better planarity and better density, but in no certain circumstances should you place less than 3 times the maximum aggregate size. Certainly the specification should be at least 3 times maximum aggregate size. Anything less is going to cause us to crush aggregate particles, which will lead to premature failures. And the sand proportion of your mixtures should be what we call fine graded, so they probably should approach about 50% of the mixture. We have different types of asphalt all over the nation in North America. Some are called fine graded, others are called coarse graded. I'm going to recommend that you look at fine graded mixtures in the area that you work because they're going to be the most conducive to the athletic asphalt requirements and guidelines that are provided by the American Sports Builders Association. And they really will lead us to a very exceptional finished product. This is a lower coarse mixture. It would apply equally as important, if not more important, to the surface coarse mixture, or as you might call it, the top coat. This is just an example of crushing aggregate. The thickness wasn't adequate, and a tennis court coating started to fall off within about 6 months, and it really just came down to crushing the coarse aggregate particles. This can be avoided with the proper lift thickness. Mixture properties will also guide the ability to get density. Again, a finer graded mix with a little more oil will probably compact much quicker and to the higher levels that we're looking for in athletic asphalt. So again, that's going to be a great reason why we should specify fine graded mixtures. That's just a picture showing different maximum particle size to one more time remind you that asphalt producers have many different mixtures available. You just need to make sure that you get the proper mixture for the day of construction. I've developed nationwide guidelines and specifications for people to use in general. They just come down to fine graded, slightly higher asphalt content, and a higher compaction requirement that's required for, as we call, density. It's athletic as well as my commercial and industrial specification. One of the crises that we can avoid is paving seams opening up. On the left is what they call a laydown mat. On the right is the direction that the paving then occurred. When a laydown mat is installed, it unfortunately exposes us to cold asphalt. Better way to do the laydown seam is to be off the court or to use 2x4s to set the screed down upon and pull off of that. And certainly we could move this seam further away from the tennis court, so a narrower laydown mat, but the owner should be prepared to route and seal that as part of the original construction process so that something like this doesn't occur. This is a very classic example of a paving seam that is opening up in a relatively short amount of time. These can be avoided. However, if you are going to build paving seams, you can control the crack by sawing and sealing them. It's certainly a much more viable option than doing nothing. This is just a photo of some installation of asphalt on a commercial parking lot to just show the areas of potential problems. If you don't pay attention, the contractor doesn't pay attention to the proper setup of the equipment, the paving equipment, and you can see the incredibly low compaction density, as we call it, on the joints. And these are primary concerns for us in athletic asphalt. And that's where I was telling you that the mat density is shown as an M and the joint density is shown as a J. Should be the same value. We need to get compaction higher. So we need specifications and testing capabilities to ensure this occurs. Air voids is going to be reduced, and we don't want them to be, as we call, interconnected. They do provide for cohesion, keeping the product together, and it makes the asphalt what we call impermeable. If you have low density when you install asphalt, then you may end up with moisture stripping your asphalt apart. This is a core that's actually turned upside down. Water traveled through 3 inches of asphalt and started to scour the asphalt and pull it apart. For athletic asphalt, if there's moisture in the mix and we put a high quality surfacing over it, inevitably the first hot summer days, it's going to start to destroy the coating. So again, we need to have higher density. We have to reduce how much moisture goes into our mixture, and we need to ensure that the installation of the coating or the materials for running tracks will perform extremely high, but the asphalt has to be dry. We ensure and measure compaction real time. You can cut cores, but most people will use either a nuclear or a non-nuclear density gauge. So we do roller passes to find out where we meet the density, and then we must stick to that minimum number of rolling passes. These are just some pieces of equipment in general. I'd just like to say everyone needs vibratory rollers. They need to be wider and bigger than is typically used by contractors, but we do have to build really high density. In order to qualify that, we have to have a density technician on the site full-time. Here's an example of a density technician doing a great job working with the contractor, checking compaction real time, working with the crew to ensure the asphalt's hot, proper ingredients, installed to the right thickness, smoothness, and density, and also checking on planarity. The asphalt on the left is a roadway that shows exceptional matte compaction, the middle of the roadway. On the right is a photo that shows incredibly poor compaction at the joint. It's a visual. You can see it gets darker and that the moisture is traveling through it. In this case, I'd be inclined to suggest that that asphalt 6 inches wide be saw cut off, removed, and replaced. Otherwise, it's going to cause a problem on our athletic asphalt with low density, high moisture retention, and therefore failure of the coatings. Essentially, we need to work with roller operators to hang out on the joint and get higher density values. This is a classic picture of working with a roller operator and explaining the importance of compaction at the paving seams. So we essentially try to follow some simple instructions. So far I've talked about the importance of compaction of the mat and the compaction of the joint and using the proper ingredients of asphalt to be successful. It's just a nice picture showing a roller and the paving crew working together. Make sure the paving seams are tightened up at 200 or maybe even 220 Fahrenheit and above. In most cases, this can be accomplished. The contractor just has to pay attention to their paving train, how many trucks they order, and the speed that they work with in a day. It may require paving faster and using 2 rollers in order to accomplish this. This is a job by job decision by the contractor. Some other problem areas that I'd like to explore with you. Coarse and segregated material. Early on, I talked to you about the importance of using a finer graded mixture. That will significantly reduce the potential for coarse and segregated mixes that take on moisture and cause premature failure. This is for everything: athletic asphalt, roadways, and runways, and commercial and industrial facilities as well. This is a close-up of it. It kind of looks like the Badlands. There's no sand. And you can imagine how much coating material you'd have to apply if this was a tennis court or leveler. Iron pyrite in coarse aggregate is one item that can cause rust spots. Steel slag is another one. We have to ensure that our asphalt doesn't include either one of these products. There's other products in the nation that cause rusting as well, and vendors need to know that those are unacceptable for use in the top course of asphalt for athletic applications. This is a brand new facility that now needs to be repaired in some fashion and recoated. Here's an attempt to fix all of those rust spots at a location. Could you imagine the time involved in this? It's either this or remove and replace or install a new top coat. I typically request that a certificate of compliance come along with your mix design that essentially says, hey, we paid attention to what you asked us, and we don't have rust-causing products in our material. Here's steel slag that's fallen apart and is rusting. Just another example that'd have to be gouged out and cleaned. Again, iron pyrite, steel slags, and a few other products cause rusting. And most of the asphalt producers know this in their area, and they should be able to give you some pretty good advice on how to write a specification that requires certain products not be allowed in the asphalt surface course. Here's an example from a basketball court. I think you can see the asphalt's brand new and there's no vegetation around it. Typically that could lead to some impurities getting on the asphalt. Here's that course that's finished, different view, different location. There's multiple sites in Hawaii. Here's something from the East Coast where you know that moisture and debris, the grit, so to speak, of the embankment was getting onto the asphalt. And then cleaning it incredibly well before coating is going to be a very important task. Sometimes not always done perfect. And autopsy and forensic work, I should say, includes cutting cores over areas that began to crack and delaminate. And primarily it just became an issue where contaminants still existed. A lot of it in different states. This one is Hawaii. They use a highway mix instead of a low volume mix. They have very high air voids. When I told you less than 3 is appropriate, they had the tiny product known as dust or minus 200, which is really high and very highly absorptive aggregates. Ended up with an optimum asphalt over 7.5%, but it actually required more because of how absorptive the products are. Essentially, they used what we call a city or county mix when they really should have used something that was much finer, higher asphalt content, and much higher density as well. So if any dirt gets onto the top of the asphalt and then moisture, it actually penetrates into the asphalt. So now you have not only moisture, but dust and dirt as well. All of those are imperfections that are going to cause your coating to fail. Block cracking is when asphalt's too hard, usually has a real high amount of dust. Hard asphalt, liquid asphalts, we need to use a softer brand, low in-place density, a reduction in film thickness, and sometimes people use an excessive amount of recycled materials into the asphalt, which, if not properly designed for, can dry the mix out as well, harden the asphalt, and provide a lot of minus 200 or dust, which again stiffens the asphalt. So get a good design first again. This is a photo of block cracking, essentially 10 foot by 10 foot or 15 by 15 foot sections of asphalt just begins to crack. If you didn't know better, you would think there was concrete under this because the crack pattern is very similar to what happens to Portland cement concrete. Just a different location, another section of what appears to be block cracking. And then a little bit up close of some block cracking. Just some pictures to let you know. Again, in the Southwest, they used a roadway mix, not a low volume. They used hard asphalt, high air voids, and poor density. No quality control existed. So I think by now you have picked up on a common theme of how asphalt can be designed and installed improperly for this application of athletic asphalt. I was involved in the slip sheet project. That's where you install a single size coarse aggregate over existing asphalt and build new high quality asphalt. It's somewhere in the Midwest. It had the same outcome, except it got even more complicated. This is the asphalt itself, and those are very excessively wide cracks, somewhere in the 1.5 to 2 inch wide cracks. They just absolutely shattered. Moisture got in and started pushing it apart when it froze in the winter months. Upon exploration, we could see how the cracks widened from 1/2 inch to over 1 inch over one winter. And then the forensics actually dug into the foundation and found that the slip sheet wasn't adequately, well, it was adequately specified, but the product installed was not what was specified. It ended up being rubble with a high amount of -200s and clay. It became very stiff, and when moisture got in, it cracked. The cracking of the foundation actually reflected through the asphalt. The asphalt wasn't the greatest either. It had a really high amount of recycle, very high dust, and poor density. So a lot of things went wrong on this project. It was a good design. The execution on it just was not proper. Really can't say enough about quality control, making sure you check the products, do some testing of the materials, and pay attention to time of year. This is a classic example of low compaction when it's cool in Canada. Got to be really cautious after, say, October 15th or October 30th. The US is very similar in the northern tier states. Not typically a problem in the southern tier states, but if it is too cool out, then we develop fracture planes within the asphalt itself. I'll show you shortly, but essentially what we call them are hairline cracks or check cracking. In the Canadian item, again, similar. Roadway mix was used, hard asphalt, very high air voids, poor density, no quality control. The extra phenomena that caused problems was it was paved in cold weather, and then it was coated in the spring, and there was still moisture in the mixture, which caused rapid deterioration of the coating. It also allows for what we call stripping. That's when the asphalt pulls away from the aggregate, and essentially the asphalt begins to disintegrate in place, and it will not last 20 years as expected. And this is really a phenomena we can address by higher oil contents and higher compaction values. A consulting engineer stated that they thought it was groundwater that caused it, but the test results showed that there was 10% in place air voids in the asphalt when 4 to 5 is desired. Trouble will begin if it goes above 8% air voids. So probably want to target no more than 7%. Average should be 5 to 6% air voids. This is just installing a coating on asphalt that is still wet, and on the right is just the shade that was being provided by the the growth that you can see there. It's a very common phenomenon. I'm not going to spend too much time on this. This really comes down to paying attention to the time of day that you coat. This is when moisture gets trapped in the mixture. It actually will fracture the asphalt about eighth to a quarter inch below the coating. And it's because it's moisture's trapped. And in the summertime, the moisture expands, and the expansion into a steam develops a pounds per square inch that is stronger than the asphalt binder. And it will no longer hold together, and then it rips apart. Many people think it's the coatings causing the problems. The reality in most cases, it's moisture in the asphalt. This is a velodrome I went to visit locally. I never knew what a velodrome was, but that's where you ride your bikes. You can see the cracking along, and you can see the surface bubbling. In this particular case, it was moisture from below that was coming through. Cold temperature paving of asphalt is not a friend to any application. Certainly not a friend to Athletic Asphalt either. And I told you I would be talking to you and showing you some photos of check cracking, and you can see all those tiny cracks going across the asphalt. So now there's tens of thousands of little areas where moisture can get into the asphalt and get trapped. Check cracking cannot be amended. Check cracking will almost always guarantee you a failure, whether it's on a roadway, a runway, commercial industrial parking lot, and certainly athletic asphalt as well. Do pay attention to the temperature. That's why we have criteria that typically are 45 or 50 degrees Fahrenheit and rising for the installation of surface courses. I strongly recommend you enforce that. Check cracking will lead to moisture in the mix. Sometimes it's going to be excessive sands and dusts. Almost always is related to cold temperatures, and occasionally it can be related to overrolling of the asphalt as well. So a good QC technician and a foreman is going to pay attention to what's happening behind the finished roller on asphalt projects. This is just quite a phenomenal fracture of a surface course that's been coated from Canada. Sometimes there are no words. Avoid ponding at almost any cost. However, I do know ponding occasionally occurs, and then levelers have to be installed. Work with the coating manufacturer to use the correct leveler, and absolutely pay attention to the maximum thickness that you can place it. Almost all are limited to 1/8 of an inch. Some have tried to install them a quarter or greater in one lift, and then the skinning on the top captures the moisture in the product below, and then we end up with what is known as mud cracking. Here's a contaminant that's on the project. Most likely diesel, although it could be drained down. It's most likely diesel that will cause a failure of the surface coating. It'll happen fairly quickly as well. Document the asphalt once it's installed with pictures. This is the project that had the leveling in it. You can see the cracking that has occurred. And again, very common phenomena. If you try to use leveling at too thick of a lift, it won't cure properly and provide for little to no cracking. It can be done successfully. It can also be done unsuccessfully. And then here's a picture a friend of mine had sent me that just shows that they didn't even get it leveled, kind of leveled, but not totally leveled, and it began to hold water and debris. And that's what will show up on the cord after a period of time. So getting planarity is very important for the success of your facility. Sometimes you can do crack controls. This might be overzealous. Most of the time I recommend underneath the net, and then one saw cut between the quartz. This has multiple ones. This is just a picture talking about crack control. Just understand the value to it is that you can force the cracks to occur where you want them to, and then you just need to protect them so that they don't fail prematurely. It's just a typical standard I've come across. You will pay attention to the thickness of the asphalt. Usually saw cut to a depth of two-thirds of the total asphalt. And then you're gonna somehow put some type of sealant material in at the top so that moisture doesn't go in. Again, the manufacturers of the coatings are going to give you really good guidance on how to actually perform this. It's going to be a straight and true line. It's going to be a good quality saw. And then we need to make sure it's dry and then install the proper sealant material. Again, as directed per your coating manufacturer's recommendations. Here's a saw cut that, for whatever reason, was never sealed. Doesn't really make any sense to do a straight and true saw cut and then not seal it. So let's make sure we do follow the rules from start to finish to be successful. The devil's in the details. Again, whether it's a running track or a tennis courts, we need to have edge drains. We need to pay attention to water from underneath. We want mixtures that have low air voids and high density. You have to pay attention to your climate and use the proper liquid asphalt that is specified for your climate. And you need to use coarse and fine aggregate ingredients that are very high quality so that they don't leave rust marks on your finished product. So, some summaries again: failure mechanisms, high dust, hard asphalt, low density or poor compaction, and high laboratory air voids. They're all telltale signs of what typically I find when doing forensic work on behalf of people who are challenged with premature failures. And low asphalt content's a relatively frequent theme as well. And most clients are minimizing how much recycle is actually used as well. There's nothing wrong with that. There's just a cost to it. But again, there's nothing wrong with it. Many of my clients will specify mixes have no recycle in the surface courses. Those are their choices. All of the other items can cause premature cracking. Premature cracking leads to moisture. Moisture leads to failure. So what do you really need? You need a low volume mix. You need to reduce air void content. Use a softer asphalt. Specify a 1/2 inch maximum particle size for your surface course. Use a minimum of 45% sand. Crushed is preferred. And then specify DOT coarse aggregate specifications. Eliminate soft and unsound, and do not use anything that rusts. Eliminate the use of wrap, shingles, and steel slag on surface courses in particular. Require testing, quality control, and quality assurance both. Temperature, what are the ingredients, asphalt content and gradation. Watch the 200, and definitely have a density technician checking the mat and joint densities in the field. Saw cut control joints under nets and between courts if you think it's appropriate, and watch out for water. Drainage is crucial for nearly every application. A perfectly good facility is now being attacked in this photo due to lack of drainage from underneath. It's a case-by-case basis. Hire your geotechnical engineer to do a good analysis. For forensics with me, I get involved. I just need to know the year built, show me the cross-section, all the ingredients and materials, and then I'll just have at it in doing reviewing. These are things you should be able to do as well. You want a mix design that's signed. You want to make sure that the supplier of the asphalt is approved by the state agency or the province that you're working in. And then coating manufacturers have to pay attention to time of year, the weather out, if there's moisture in the mix, if they have to wait till the afternoon to do their work. A lot of things that they're experts at. Just need to kind of remind you to keep doing what you do well and pay attention to the details. Here's a tennis court in front of my house that's had failure mechanisms over the years for many different reasons. These are paving seams and roller cut marks, but they opened up quite a bit because they didn't treat them quick enough. And then those joints became excessively wide because the moisture turned into ice, frozen, and in the winter it pushed the joints apart. So you do have to do maintenance when it's appropriate. So I want you to be determined in achieving your goals. It takes teamwork. And the next webinar, well, first and foremost, make sure that you send me a link, and I'll send you the quiz for this webinar. And then once you send me your quiz, I'll send you your certificate of completion. And I'm going to look at doing more on mixed design, production, and construction for roadways and runways, industrial and commercial, in the next webinar. If you have other ideas, feel free to send them along. Please continue to be safe as you're out there working today. Send me an email reminder to tmurphy@murphypavetech.com. I'll send you your 10-question examination, some additional topics you'd like to hear about, and upon receipt of your topics and exam, I'll send you your certificate of achievement. Have a great day. Thanks for listening.
Did you do your quiz? 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 Did you do your quiz?
Hey, but in all seriousness, please stay safe. Take care of yourself, take care of your family, take care of your crew, and have a very productive 2020 construction season.